Okay, lesson 6.1, starting off the chapter, we're going to be looking at ratios and rates. A ratio is just something that uses division to compare two quantities. So we can write that in. Alright. I'm going to abbreviate with the division sign. Uses division to compare two quantities. So that means in quantities represent numbers. So uses division to compare two different numbers. Now equivalent ratios are ratios that are equal. Now up till now we've defined ratio, uses division to compare two quantities, but we haven't looked at any yet. So an example, let's draw in a couple possible, we want the colors. Okay. A couple ratios. This could be a ratio. This could be a ratio, or something completely different. This could be a ratio. And we're going to look at that down here, but notice that there's different ways of writing it, and this one might be tipping you off. It kind of looks like a fraction, and you're right, it is a fraction. So ratio, if we're just speaking of this one in particular, is something that we've already been studying for quite a while. So that's going to come in handy throughout this lesson. Alright, so let's take a look carefully. Writing ratios. You can write the ratio of two quantities, so two different numbers, and they're going to use A and B is not equal to 0 because again you can't divide by 0, in three different ways. We can write it A to B with the word 2, A colon B with a colon, and A divided by B. So let's say A is 4 and B is 7. We could write it 4 to 7, or 4 colon 7, or 4 over 7. Now notice we're using division to compare two different quantities, and that's most obvious here because fraction means to divide. We're using the division to compare two quantities, and this is also using that same concept. So when we read it, we say each ratio is read the ratio of A to B, and you should write the ratio in simplest form always. So just like a fraction, you're going to reduce. So A to B, the ratio of A to B, the ratio of 4 to 7. Let's try example 1. It's Team 7A's top basketball player shoots 30 free throws, with 19 of them being successful and 11 of them being misses. Using this information, write the following ratios. Alright, the number of successful baskets to the number of misses. Okay, successful baskets, there was 19 of those. To number of misses, there were 11. That's one way of writing it. We could also write it 19 with the colon 11, or 19 over 11, and all of these would be read the ratio of 19 to 11. Letter B says the number of successful baskets to the number of shots. Successful again was 19, but there were 30 shots, so we could write 19 to 30, 19 with the colon 30, or 19 over 30. And we want to simplify, but these two numbers are relatively prime, so that's as simplified as it can get. Example 1, you try. Compare the number of misses to the number of shots using a ratio. So 2. Number of misses, there was 11 out of 30 shots. So 11 to 30, or 11 colon 30, or 11 over 30. Again, they're all simplified, and these are three different ways of writing the same thing. Let's take a look at this second page. We're going to try using this information to compare things. So to compare two ratios, you can write both ratios as fractions or as decimals, and then two ratios are called equivalent when they have the same value. That's what we wrote on the page before. So example 2 says the ratio comparing the length of a bird's wings to the average width. So that's the important thing here. Length of a bird's wings to the average width of the bird's wings is called this aspect ratio. Then they want us to order the birds in the table from the greatest aspect ratio to the least. So we need to find out what the ratios are, and then we can order them. It's going to be length to width, and luckily they put length first, width second. So we're just going to use this information right from here. The white-tailed eagle has a length of 209 and a width of 30, so I can write it as 209 over 30. The European jay has a length of 47 and a width of 12. And the black-headed gull has a length of 83 and a width of 8. And since they're both the same units, we're good to go. Now they want us to order this from greatest aspect ratio to least. So we know with fractions, as we've called them in the past, and we still will for many cases, we need to get common denominators if we're going to order anything. Well, here we don't really have to do that. We have other alternatives. Now that we're using calculators, it's going to be a lot easier if we just find the decimal value, and then we can go ahead and put them in order from there. So 209 divided by 30 is going to give me 6.96 repeating. 47 divided by 12 is going to give me 3.91, and the 6 is repeating again. And 83 divided by 8 is going to give me 10.375. When I write that out, it's obvious to see, all right, the largest is this black-headed gull. That ratio is largest, so black-headed gull. Then the next smallest would be this white-tailed eagle, and the teeniest ratio, aspect ratio, the smallest one is the 3.916 repeating, which is the European jay. And you would want to write them out, but I'm just going to take care of it there. So, alrighty, that was bouncing and maybe distracting you, maybe not, but let's get back to the problems here. Let's look at rates. Now rates we've already talked about earlier in the year, and rates are basically just a specified version of a ratio. A rate still uses division to compare two different quantities, but it also uses units. So it is a ratio, basically, in short, with units. So something like this: 5 feet for every 2 miles. Maybe you're talking about a scale or something like that, where you're comparing, using division, comparing two different quantities, and we also have two different units. We can add that in there. So a rate is a ratio with different units. Now that's an example. Maybe a common one is miles per hour. We've talked about that before, and you could have numbers here. Feet per second is another one. There's tons of them, tons of different rates. Now there's a specified thing called a unit rate, and that's when you have a rate with denominator of 1. And many of the rates we talk about have exactly that. They have denominators of 1. So it would be something like 30 miles per 1 hour. And we just write it as 30 miles per hour. But we want our denominator to be 1. So in example 3, you host a party for 12 people. The food and drinks for the party cost $66. What is the cost per person? So there's 12 people. Okay, $66 for all of you. So you want to know the cost per person. So what you want in the end is money for every one person. So we want to set that up in a similar form. So we're going to do $66 for 12 people. And then we can divide. 66 divided by 12 is going to tell us that it's actually $5.50 for one person. And that's how we get that. The last one, a jet flies 540 miles for every 1 hour. Write its rate in miles per minute. So they want miles per minute. So what we're going to do is multiply or divide by 60. When I divide 540 by 60, I get 9, and my final answer then is 9 miles for every 1 minute. All right, good job, guys.